Okay, so we've got a little job to do here today. Is a repair on the ram part of a electric chair. Is not really the right word to use, is it? It's a chair that reclines, electric reclining chair that allows you to extend the footrest out to make it more comfortable and also recline back. So these two have come adrift here. It looks like a plastic piece of thread that joined this union where it bolts to the chassis of the chair, and this end goes into the ram, which screws down into the mechanism. Now this is broken off here. I believe that looking at this, it was probably made in a one piece. It's just that they've got this piece of metal in here, which makes me wonder if it's possible that this is threaded into here as well as into there. So what I'm going to try and do first is to drill a couple holes in here and see if I can use a set of strong dividers as like a pin wrench to see if I can unscrew that out of there. It's not that thick, so it makes me wonder whether this was sort of cast as one plastic and they put this here as some sort of strengthening mechanism. Yes, so that's what I'm going to try and do first. Okay. So, as we say in the classics, safety second. I'm going to hold this and drill at the same time. What could possibly go wrong? I'm not seriously going to drill it very hard, so I can't really see too much of an issue, but I guess we'll find out. I only want to drill in a little way, just so my dividers might be able to get a better grip on there and unscrew this. It would save a lot of time if this actually came unscrewed. Now that just drilled through, so that could have been nasty. So I reckon that's like I thought, and that was a full piece. I will try though. It may come undone, but I doubt it. Okay, so this is my thoughts. Nice strong set of dividers. This may be called tool abuse, but just going to see if I can pop that in there, and if it's threaded inside this insert here, which I don't think it is, it might come undone. No. Okay, so back to the drawing board. I'm going to have to replicate this whole head to fit into this tube. So the closest, I really wanted to make it out of aluminium, but unfortunately the closest piece of aluminium that I have is this. And look, I like making chips as much as the next guy, but that's going to be ridiculous how much material I've got to take off. Next is brass. I've only got this piece here, and by the time we make the length, including the thread, which I pop out of here, it's not going to give me good holding in the chuck of the lathe. So we've already done one danger mouse move, so let's not continue that on. So that guy really is out. This piece of brass, I've got some hex. I think it's inch, something like that. Now that is slightly too small. Let's not under-engineer it. Let's sort of over-engineer it, if anything. So I've decided that next best thing just to get this job done is to use a bit of steel shaft that I've got here. That's the closest. And so that's what I'm going to decide to do. We'll just make it out of steel. I'll probably hollow out the inside before I'm finished, just to try and lighten it up a bit. But look, it's part of a chair that weighs a ton, so I really don't think having that head in steel is going to be much of a problem. The fact that it broke means we make it out of steel or will not break again. Although if you saw my mama, you'd know why it broke. Now, of course, that is tongue-in-cheek because my mum is actually only a very little person, so just years of wear, I suppose, and to and fro. Plastic eventually gave up. Yeah, so we'll throw it in the lathe and we'll start it. Okay, time to put the shaft in the lathe. Now, I'm only an amateur, very amateur. I'm a welder by trade, but I'm not a fitter and turner. So, even though this is round stock, I have trying to give myself a bit of a challenge of using 4-jaw chuck. Practice getting used to setting it up and all that sort of gear. Okay, so I was slightly interrupted by the wife coming in. So, okay, so what I've done is I use these lines on the jaw, on the chuck, to get it rough. And then you can see she's out. So, use our indicator here, and if you're starting to do this sort of machine work and that, these Noga arms are amazing. I started off with the old standard style arms. Let me grab one. This sort of arrangement, where you've still got movement and all that, but it's all individual, you know, adjustments and things, and they're just pain in the bum to use, especially on lathes and stuff where you need to have some weird angles. So, only a newbie really at this sort of stuff. So how I work it out is I do a high versus low sort of routine in my head on two opposing jaws. You've seen all this stuff done way before. There's no point in me really going on too far about it. And so what I like to do is I move me. Oh, that didn't go too well, did it? Tighten that up. Okay, so let's just move that back into the centre of the shaft. Make sure I'm not going to hit anything. Okay, so I look for the lowest point and put my 0 there. So basically our lowest point is here, and my highest point is all the way over here. So what I do is I tighten the highs and loosen the lows. So this is a high, so have we got any play in there? A little bit, so we need to go more. So then I'll crack this bottom one and tighten the high. That stops me from getting confused, which is easily done. And if you're still a little bit confused, then I'll just reset the 0 roughly there, and then look for the low again. Okay, so our low is here now, and our high is sort of on this jaw here. So I'll tighten down a little bit, not too much, so loosen it and tighten down the high. Rightio, where's our low now? So this is no A-bomb trick, that's for sure. This is just how I do it. So low is about there, high about here somewhere. The jaws are already reasonably tight, so let's back off underneath, tighten. Now where's our low? Low is there somewhere, and our high is on this guy. It's only a little bit, he might tighten up. Smidge. Now that surface is pretty rough. Let's go back to there. And I've now realised that I'm really not showing too well the indicator. But anyway, you get the gist. So now that's the low there. high, sort of in this area. Let's just tweak him a little bit. That's pretty tight. So needle's really just bouncing on the rust and stuff that's on this shaft, so you know, that's near enough. And of course, as you're learning, you make all sorts of mistakes, including this one, which is nowhere near long enough for me to machine that off. So I'm going to back 2 jaws off, which is usually I mark an X on 2 of them, and then so hopefully undo these 2. And that's a little trick that I've sort of learnt from watching Joe Piezinski. So I'm just going to back these 2 off, which I'm not showing you. So back these 2, slide out our shaft. That's going to be a better length, and do these 2 back up, and we shouldn't be too far off. So I will have to redo that though, so we'll come back in. You can see the rightio. So that's how high there. There's a little bit in it. That's what, 0.101 of an inch or something or other, so not a lot, maybe a little bit on this one. Yeah, it's just bouncing on rust, etc. Rightio, we'll remove the, it's just why these Nogas are so good. There we are. All packed up. Pop it away, and then yeah, bring it back out. Undo 1 knob. Okay, so we're looking for a diameter of about 30mm and a length of about 70. So let me mark this. Okay, it'd be handy if I had some power on the lathe. That'd be even better, wouldn't it? So, just using a marker here, so it shows up the line. It doesn't really matter too much. This isn't a precision part, just as well because I'm making it. Camera's sort of in the way of bits and pieces, so I'll just put that on there. This is a bit more tool abuse. Okay, so what I like to do is find the right tool. So because I don't have exactly the right tooling that would be conducive to making this work out perfectly, sometimes you've got to wing it. So what I like to do is to get that shoulder is to use the parting off tool down to a certain bit then turn into it. Probably, I don't know, just the way I like doing it. Everyone works differently, I suppose. Right, put this lathe into a little bit faster speed. That'll give me a starting point. I made a couple, well, not a couple, 4 brass knobs from a milling machine the other day, and the brass got everywhere. On the floor, it's just amongst everything, and why it cuts easy, it's a muggle to clean up, so that's why everything's covered in brass at the moment. I really only was able to do a bit of a like a lick and a promise as far as tidying my machine up. I'll grab one of these knobs and I'll show you what, just if you're interested at all. So, the other knobs that I made from my milling machine, I really do not like those lever knobs that you have to pull out half flat on the hex to tighten back up again. They're a pain to use. I understand why they make them, so you can get into awkward spots. I do have them here. That's basically what, so that's how they sort of work. Pull out half a turn, but I'd prefer to use a nice knurled. And I made the knurling tool from Tom's Techniques. He's got a project on there to make the knurling tool. I did make a bit of a mistake, of course. I put 2 lefts or 2 rights, I can't remember what it was, knurls in the tool, so it doesn't do the diamond shape. It only does just like a single knurl, but I'm calling it a design feature. It does actually not look too bad. Okay, so I've got a decision to make. Last time I used the lathe, I was building these, and I did this thread, which is 1.5 pitch, 1.5 millimeter pitch, being a metric thread. Now I need to use this for machining across to reduce this diameter. What that's going to leave me with, unfortunately, is with this lathe that the feed rate, even though we're not using the half nuts, the feed rate for the saddle is going to be too fast. It's going to end up giving me sort of like a very, very fine thread itself on here. So I've got 2 choices. Either I rough it with the ratios of the gears that's in there at the moment, or I change the change gears. Now this is an issue. Wish I'd known this a bit more about this lathe and lathes like it before I bought it. For the average guy that doesn't want to play with threads and stuff, just want to use thread, just use it for turning and drilling operations and that's fine. If you have a lot of different projects in which you're going to do a lot of different threads, change gears is a real pain. The only good thing about change gears is once you have that gear in the train in the back there, your thread pitch can't be wrong because it's locked, it's in there. But if you then want to do different operations on the same thing, bit of turning, bit of threading, I don't know why you may do that, but if you've got more than one project, more than one item, and the item can't be just parted off and then threaded all at once, it had to be done the operation and then parted off and just do something else and then do the next operation, then do the threading, you'd be forever changing change gears. So think about that for anyone that wants to buy a lathe with change gears. A gearbox is the way to go, but it was a different price point. Basically, I've always sort of wanted a lathe, but never could justify it. The place I work at supplies industrial equipment, and one of our customers needed some brass fittings made up. They were specialised, and I can't remember now whether we couldn't get them or they were astronomically expensive, one of the two. And I thought that I could make them, so we put a price in. I did a demo of one first before we put a price in to our customer, and yes, I could make them. While I didn't make a lot of money out of it because there was high amount of labour in it, it did actually buy me this lathe. So it's I think it's a 600 between centres, 300 swing, is it? No, 300 diameter, so 150 over the bed. It's been good, but it's a cheap Chinese lathe, and you get what you pay for. So let's have a look at the change gears.